Okay, so let's take a look at today, part 1. Go ahead and find the rational roots. How many are there? What are they? Yeah, all the factors of 13 are plus or minus 1 and plus or minus 13. Okay. Now what we have to do is actually figure out exactly which ones are the roots. Okay. Here's how we're going to do it. Just watch it. Watch me do it the first time. So here's an example. If I plug in -1 through synthetic division, which means I just take the coefficients, and I go through the process. That's the setup. You always bring down the first number. You multiply -1 times 1, I get 10. -1 times 10, and we get -35. And -1 times 35. And you can see we get a remainder, right? So that means -1 is not a root. So now we have to try a different number. Okay. Let's try positive 1. 1 times 1 is 1. We get 12. 1 times 12 is 12. We get -13. 1 times -13 is 13. And we get 0. So that means because this is 0, x equals positive 1 is a root. Okay. How many roots are there total? 3. So we're on our way. So far I know this. I need 2 more though. Alright, so that's part 1. It's going through this list right here until you get 1 or 2, depending on the problem. 2 of them or 1 of them that give you a 0, which means they're a root. And you have to keep doing this until you're left with a quadratic. So on this problem, since we started with x to the third and we found 1 root, what we're left with is actually, what does this mean right here? The 1, 12, and -13 means 1x squared plus 12x minus 13 equals 0. It turns into just a normal old quadratic. So do you know how to solve that? Okay. And how do you want to solve that? So you have a choice. You can quadratic formula, you could do complete the square, you could do factoring. Yeah, try factoring first. Does it work? Yeah, what 2 numbers multiply to -13 add to 12? What are they? 13 and -1. X plus 13, x minus -1, or x minus 1. Solve them. There's our second root. Here's our last root. Now you will note that our first root was 1, and our third root we got here was 1. So it's okay if you have this thing called multiplicity where you have a double root. Okay, if that's okay. We'll just list them all down here. Okay. And this is all you need to do for each problem. I'm actually going to show you, just to show you graphically, what does this mean? Okay. So here's -13, x equals, here's 1. And the fact that we got 2 of them equals 1 means a double root. It means it's going to bounce off the x-axis, it's not going to go through. So here's a possibility of what the graph could look like. Go here, it'll bounce off, it'll go back up, and it'll come back down. Okay, so that's what this means. Remember, we spent a whole bunch of time with t-charts and things like that. We don't know, I don't know exactly how high this will go. I know that this part will not go below because a double root means that it bounce off, it won't go through. But I do know the end behavior is as x goes to infinity, f of x goes to infinity because it's x to the third. And as x goes to negative infinity, f of x goes to negative infinity as well. So that's what these answers actually mean. There are roots. We spend a lot of time doing this with quadratics. We're doing the same thing with cubics and anything above. Okay, but you don't have to include the graph. I'm just showing you what they mean. All right, so let's go ahead and do. You want to do another one? Or are we good? Okay. In that case, let's go down to number 5. All right, same idea. What are all the possible roots of this? Plus or minus 1, 2, 3, 6, 7. 12 doesn't go into 42. 14. So yeah, this means that you might have to try a lot of numbers until you find the one that works. So if you want to, you can use another piece of paper, do all the busy work until you actually find one that equals 0. I mean, you could try, for us, let's try 1. We have 1, 5, negative 38, 42. Bring down the 1. It's all set up. 1 times 1. 1 times 6. 1 times negative 32. This isn't going to work. Because I'd expect to get a negative 42 here for it to work. So.
Is there a quicker way?
Nope.
This is the only way?
This is it.
Like ever invented? It's the only way?
Calculator. Let's try negative 1. Negative 1 times 1. Negative 1 times 4.
Hey.
Does it work?
No.
Ah, it doesn't work. Yeah. Let's go back. Let's try 2. 7. 14.
No good. Oh wait, yeah. No good.
We get negative 48.
I don't even think negative 2 is good.
You want to try negative 2? You want to try 3? What do you think?
I think
Negative
6.
3. Negative 3. Negative 3.
Negative 3.
You guys just keep the boxes.
Negative
I
3.
can't hear you. This is the money.
Try positive 3.
Yeah.
No, that's no good. No, it's no good. Oh shit. Oh, it is.
Oh.
Called it. Positive 3.
So you can see the process, but if you can do this quickly, you know, each one of those took, what, maybe 15 seconds? So you're saying, I have to try 5? That's going to take a whole 75 seconds? Not that big of a deal. A little over a minute to try three or four numbers if you're focused and just, you know, cranking it out. If you're distracted and, like some of you say, oh, it didn't work again, and you have to stop for a minute and complain about it. If you just start the next one, you'd be finished faster, right? So don't think of it as a guessing game like you got it wrong because you didn't get it the first try. Just keep going through until you get it, and it'll happen. So what does this mean again? Okay, yeah, first thing is x equals 3 is a root, and we have x squared plus 8x minus 14 equals 0. So I know this. X equals 3. How many more do I need?
2.
2 more. All right. So try to factor it. What two numbers multiply to negative 14 and add to 8? That doesn't work. So factoring doesn't work. Quadratic formula, complete the square. Which one?
Complete the square.
Yeah, completing the square is going to be faster. How do I know?
Because
This is a 1, and this is even. If this is a 1 and this is even, completing the square is going to be the fastest way. If this was like 7 and this was like 5, you know, it'd be really ugly with complete the square, quadratic formula. So here we go, complete the square. We have x squared plus 8x, leave a space, equals 14. Set everything all up. So as you can see, we're not doing anything new so much as that we're using everything we already know. A lot of the skill here and how well you do on the test and quiz is going to be your decision-making process. Not how well you do this, but do you know to do completing the square here and why? Do you know that factoring doesn't work? Or are you going to just try to do quadratic formula on everything and have it take forever? So that's going to be the main skill that you're going to need to develop over the next few days, is knowing when to use which method, not only for the rational roots, but also for the stuff we did before with quadratics. So half of 8 is 4. 4 squared, 16. 14 plus 16, 30. Square root. So we have x plus 4 equals, now does root 30 reduce?
no.
Does it reduce? No? Okay. So we get what? Plus or minus root 30. Lastly, subtract 4 on both sides. And we get x equals negative 4 plus 30, root 30, and negative 4 minus root 30. So there's our two other roots. And we're going to leave them as the exact form. We're not going to do decimals. But if we did, what would this mean? This would be like 1.2 and negative like 9.8 or something. So if you graphed it, it'd go through, if I did a little sketch, this is what it looked like. There's 1.2, here's 3, it'd probably come down, go back up, come back down. Right. The y-intercept is actually 42. So it'd actually go up really, really high. Right here would be like 42. Well, I know all cubic functions start up here, that end behavior. They all start here and end here. So I just kind of know, I don't know how far, this might go down further, this might go way up, but I know it goes through these numbers. It starts up here and it ends down here. That's how much I know. And I know this is going to be 42. The y-intercept is going to be 42. Alright, so there's one that factors easily. You just get nice rational numbers for all roots. Here's one that where you get some irrational roots that, yeah, before on your, I think your first homework assignment, we didn't know what this decimal was. We just said, oh, the root's between negative 9 and negative 10. But we weren't able to say it's exactly this. Now we are. Okay. One more. First of all, any clarifications on any of these? Do we need to talk about anything before we move on? Okay. So let's go to the back. 9 through 12, I gave you some review problems that we can use. Now, here's again, remember I just mentioned that decision-making process you have to develop. Should we go through all the rational roots of 64, or is this like some other special type of problem? Yeah, this is a sum of cubes. So right there, that decision, that recognizing that this is a sum of cubes, will save you so much time. So it's not so much can you, solve the problem, but can you make a decision, the right decision on what kind of method to use. So yeah, this is the same as x cubed plus 4 cubed. And that means we don't have to go through all the roots, possible rational roots, and do synthetic division. We already know how this factors. If you know how to factors, you don't need the synthetic division. Okay, so do you remember how this works? Okay, this is going to be, the same. So then we're going to have x squared minus, so these two are always opposite, and it's always just multiply the two things being cubed. So 4 and x make 4x, and then the last one is 4 cubed, which is 16. And this one, remember, is always positive. So yeah, and this equals 0. We don't have to go through and do any synthetic division. We didn't have to say, oh, the roots are 1, 2, 4, 8, 12. We didn't have to go through and do any synthetic division. We already know how to factors. Yep.
You got the 16 by 4 squared or 4?
4 squared, yes. So this term is always going to be whatever this is squared, and this term here is going to be whatever this is squared. All right, so here we go. So x plus 4 equals 0. So x equals -4. So we got one of our 3 roots already finished. That's -4. So we can say x equals -4. All right, let's factor and solve this. What two numbers multiply to 16, add to -4? None. Factoring doesn't work. All right, so decision time. Quadratic formula or completing the square? Yeah, once again, this is probably better completing the square. We've got a 1 here, and that's even. So here we go. X squared minus 4x. Leave a space, equals -16. Move the 16 to the other side. Set it all up. Okay, half of -4. Square it. Both sides. And we get here -12. Which means what? What kind of roots do we have? Yeah, these are going to be imaginary or complex. They'll probably be complex. So we have x minus 2 equals square root of -12. Simplify it, what do you get? Plus or minus 2 pi, root 3, good. And then add the 2 over. So there we are. X equals 2 plus or minus 2i root 3 for our next 2 roots. So it's good news, bad news. If you've done your due diligence studies and you did very well on the quadratic test with all the completing the squares and everything, this is a cinch. Oh, now I just do that? Okay. But if you didn't really study up on it before, it's not going away. So it might feel like you have double the workload because you have to figure out this new stuff, but you also have to go back and learn all that other stuff that you maybe didn't in the past. It might feel like a lot of work in that sense. So if that's the case, just stick with it and ask for a lot of help. Don't think you have to do it all by yourself. get the help that you need. Okay, so yeah, small picture is make sure you know how to get the answers. Make sure you know what the answers mean, right? That there are x-intercepts. Big picture, know how this fits in all the other problems, that you can choose a long path or a short path. If I just tell you on a quiz to solve this, if you can tell real fast, like, it's only 1, -1, plus or minus 13, that's going to be really fast to solve. And if I give you, like this difference of cubes problem, but you try to do all the rational roots here, it's going to take forever. You're not going to have time to finish. So it's really that the big picture is that decision-making process. And also the little things here, like quadratic formula, factoring, completing the square. The first one we did factoring up here, look how fast it was. Oh, x plus 13, x minus 1, we were done. If you try quadratic formula, completing the square here, it takes longer. So that's the big picture, is your decision-making process. And we'll practice this tonight. We'll do this tomorrow in class, so you get a lot of practice. And of course, if you can, check with people as you go along just to make sure you're doing things correct. I don't want you coming in tomorrow realizing you did the same mistake on every problem. So check as you go. Okay, you guys are ready to go.